Hi all, welcome to lesson 3. Today's topic is factoring expressions. So I want you to pause the video and try the warm up on your own and also try to fill in the blanks, see if you know them. Okay, so the warm up says explain in your own words how you would factor. So the first rule for factoring is always to look for the GCF. So the first thing that we're going to do is look for GCF, which is greatest common factor. Here your GCF is something that's common to all your terms. We have two terms here, so our GCF is 3x squared y to the third, right? And then I'm left with the remaining, so the remaining is sorry about that, y squared minus 4x to the sixth, right? Now, after the GCF, always check that can it be factored further. So if I look at this quantity here, this is two terms and they're perfect squares with, right? Oops. So this can be factored further. So what would it factor to? So that's called dots, a difference of two perfect squares. So this would be y minus 2x to the third and y plus 2x to the third. So our second step would be dots, or you can elaborate it and write it difference of two perfect. Okay, so take a moment and check your blanks, and I'm gonna talk about two special products, that is difference of two squares and sum and difference of two cubes, right? So difference of two squares can be expanded to a minus b and a plus b, right? With the sum and difference of cubes, I want to do both of them together. I'm going to set up my two parentheses, right? So how I do it is, it's like very little memorization. I write my bases. So my base here is a, b, and I'm going to do the same thing here also. And then I'm going to square the first, multiply the two, so a, b, whatever the bases are, and then square the second. And I'm not sure if you remember SOAP. I'm going to write it here. I'm going to actually use a different color so that you can see it. SOAP. I'm going to write that. What does that mean, or what does it stands for is SOAP means same sign. So here it was minus. I'm going to use minus. Opposite sign, which would be plus, and always positive. That's what SOAP stands for. Same. So this would be plus. Opposite, minus, always positive. And that way you do not mess up your signs and it's easy for you to remember. Let's start with the examples. So again, always remember the first rule is to look for your GCF. So here, remember your terms are separated by addition and subtractions. We have two terms. What's common in both of them? We have 3x plus 1, right? So what am I left with? In my first one, I'm just left with x cubed minus 5 parentheses. I already took out one quantity, so I'm left with just 1, right? And now I'm going to simplify this inside. This can't be factored further, but I can get rid of those parentheses. So I'm going to leave this as it is, my first parentheses, and this would be x cubed minus, distribute the negative 5, so it'll be negative 15x minus 5. You can't factor any of it further, so that's it, it's factored. Letter B, again, start with your GCF and see if you can see any special products. My GCF for 5 and 45 is just 5, right? Between the variables, whenever you're factoring them, always look for the lowest term. So a square and a6, it'll be a square, and b to, oh sorry, there's no b in the other term, so I can't really factor. So 5a squared is actually your GCF. And what are you left with? You're left with b to the fourth minus 9a to the fourth, right? So now look at this. Is this a special product? This inside is a special product, so I'm going to factor it further, which would be b squared minus 3a squared, and then b squared plus 3a square, right? Again, you should always check this cannot be factored further, although b square and a square are perfect squares, 3 isn't. So you want to make sure that you continue to check, because you must factor them completely or you end up losing points. Okay, so now the third one, we have two terms, and again, this is one of our special products. It is sum of two cubes. You can choose to write your formula up above, so if it helps. I actually like to break it down. Eventually you don't have to, but 1/8 can be rewritten as 1/2 x to the third plus 1 cube. This makes it easier to apply the formula. And now I'm gonna do, we wrote it out, we're going to set up two parentheses, and I always like to do it as the first base, the second, and I'll do the signs later. Square the first one, so it'll be 1/4x squared. Multiply the two, so it'll be 1/2 x only, and then square the last, so it'll be 1 squared. It's just 1. And now do SOAP. I'm going to write it as OAP. That's why I changed colors. So if you don't want to use SOAP, go for it. You don't necessarily have to. So same, it is plus, opposite sign, minus, always positive. Okay, letter D. So now again, look at your two terms. This is the first one, and I'm going to say there's an invisible one here, and this is the second. What's common in both of them? 64 minus p squared, right? What am I left with? P squared minus 1. And check, can these be factored further? Yes, both of them can be, because they're perfect squares. They're difference of two perfect squares. So this would be 8 minus p and 8 plus p. This would be p minus 1 and p plus 1. And that's basically it. So now I want you to finish the problem set on your own, and don't forget to check the answers from my answer key. Once they're all submitted, I'll post the answers.